Our digital globes suggest a solved puzzle. Satellites can chart a single suburban street or the highest peak of the Himalayas in perfect, high-resolution detail. These maps stop at the water's edge. Our view of the deep ocean floor is a composite of guesswork and low-resolution sonar scans. This data shows the reality of our current knowledge, a blurry, golden-hued rendering of a 2,500-kilometer scar in the crust. Hydrostatic pressure creates a physical barrier more absolute than darkness. Every 10 meters of descent adds another entire atmosphere of weight. At the trench's bottom, 11,000 meters down, the weight is 1,100 times greater than on land. That pressure warps solid steel and crushes bone. It forces matter into states that flatten surface creatures, requiring biology's building blocks to operate under a relentless weight. The Mariana Trench remains a blank space on our maps because its physical power pushes back against our presence. We assume a place devoid of light and warmth exists in absolute silence. But when researchers lower titanium-encased hydrophones into the abyss, they find it is one of the noisiest environments on the planet. This noise is trapped within the deep sound channel. At this specific depth, a unique combination of pressure and temperature acts as a natural amplifier, allowing sound to travel horizontally for thousands of kilometers without losing its energy. This channel carries the groans of grinding tectonic plates, the rumble of distant typhoons, and the songs of baleen whales echoing from entire oceans away. Some recordings remain unidentified. In 2014, instruments captured a 5-part call ending in a high-pitched metallic twang. Known as the Western Pacific biotwang, its mechanical quality does not match any known geological event or species of whale. The trench acts as an echo chamber for the entire planet. If we were wrong about the silence of the deep, it suggests our other assumptions about this environment are just as fragile. We expect the apex predator of this environment to be an armored leviathan, built with a thick shell to resist the weight of the water. The actual ruler of the Challenger Deep is the Mariana snailfish. It is about the length of a human hand, has no scales, and its pale, translucent body is supported by a skeleton made of flexible cartilage. To function at 7 miles down, the snailfish uses molecules called piezolites. These act as structural braces, preventing membranes from being squeezed shut by 16,000 pounds per square inch of pressure. But they only work under high pressure. Brought to the surface, these internal braces fail, causing cells to dissolve into a gelatinous slurry. The environment also creates gigantism. Tiny, fingernail-sized surface crustaceans, like amphipods, live here as pale, armored giants the size of an adult's shoe. Survival at this depth is a matter of biochemical integration. Instead of fighting the pressure with armor, the snailfish uses it as a structural component of its own life. On the surface, the sun provides the energy for every food web we know. Below the light, volcanic activity creates a different energy source. Hydrothermal vents blast superheated, acidic fluid from the crust, while the champagne vent releases streams of pure liquid carbon dioxide. Surrounding these vents are tube worms and blind crabs that survive via chemosynthesis. They draw their energy directly from toxic sulfur and geothermal heat. These chemical furnaces may be where life first assembled itself. The hydrothermal vent hypothesis suggests that the interaction between superheated acidic fluid and cold alkaline water acts as a natural battery, providing the energy needed to organize the very first biological molecules. This chemical-rich system is why astrobiologists are interested in the icy moons of our solar system. If life can take root in the dark of the Mariana Trench, it may also exist beneath the frozen crust of Jupiter's moon, Europa. Because the trench is so inaccessible, we assume it remains an untouched sanctuary. Reaching the Challenger Deep requires the absolute limits of human engineering. When James Cameron stood next to this 24-foot-long torpedo, he was preparing to enter an environment more isolated than the International Space Station. At the absolute bottom of the world, Cameron didn't find an untouched wilderness. He found a plastic bag. Throughout the Cold War, the trench was a default landfill for what we wanted to forget. It holds scuttled spy technology, toxic heavy metals, and steel drums of radioactive waste that are now slowly rusting and cracking open under the weight of the water. The trench's V-shaped geometry acts as a funnel, concentrating this toxic leakage into the silt. From there, it enters the slow food web of the scavengers, proving our influence has reached the bottom before our explorers. Now, a new industrial interest is focusing on the abyss. The minerals that accumulate around hydrothermal vents are rich in the rare earth elements needed for modern electronics. Dozens of corporations are developing robotic harvesters designed to drop 7 miles down. These submersible grinders would crawl over the vents, crushing the life-filled chimneys into a slurry to be pumped to the surface. Although the trench is a protected monument, ocean currents do not respect maps. Toxic sediment plumes from mining in international waters will inevitably drift, burying the very ecosystems the sanctuary was designed to save. The Mariana Trench is our planet's final wilderness. While its minerals could power our devices, their extraction would erase the very vents that likely allowed life to begin. We need a place that remains unmapped and undisturbed, reminding us that parts of our world are still beyond our control.